Welcome to our first online lecture. We're talking about agriculture. We were talking about agriculture for the last couple of minutes of class on Thursday, and I'm going to go over the points that I made on Thursday and then continue talking about different stuff with agriculture. Okay, so I have called this our oldest environmental problem. And what I mean by that is we as humans are part of our biosphere. We think of ourselves as being somehow separate from the environment. We say things like we have to save the environment when we're actually a subsystem of our environment. So, what I mean by our oldest environmental problem is that since we've been around, since we've been humans for 150,000 years, getting enough from the environment, getting enough food, getting enough water without overtaxing the environment, meaning growing enough plants so that we are able to sustain our population, so that we're not starving, but also not leaching the soil, not using the water system in an improper way, all that kind of stuff. So, we're going to focus our lecture on our oldest environmental issue, how we've dealt with it, how we've developed it, but also we want to look at how agriculture has changed culture, because agriculture has been the defining point in how our culture has developed. So let's get started. All right, I have a couple quotes for you. I think I've given you a Sixto Rodriguez quote before. He's a folk singer. He's the subject of a documentary I'm going to give you as extra credit for your final. But you can keep your symbols of success. Then I'll pursue my own happiness. And then this is something that I have said in class before, and I'm sure you are not surprised by that. All right. So here is Asia, a little bit of Africa. Now, if we're talking about agriculture, we're talking about evolution, not human evolution, but evolution of a system. So we've talked about this in class before, but I'm just going to remind you, agriculture starts in Mesopotamia. So it starts in modern day Iraq, right here between the Tigris and the Euphrates. Now, we're from here. Humans come from right here. We've been around for, a good 150,000 years, but we spent most of that time as hunter-gatherers. Now, hunter-gatherer societies worked very well in this part of the world. There is a surplus of sunlight, a surplus of the sun's energy, there's a surplus of water, things grow very, very quickly, there's a lot to eat, there's a lot to hunt, but there's not a lot of domesticatable plants. So it wasn't until we left Africa and made our way up into Southwest Asia that we developed agriculture. And it was a long time after we left Africa. It's not like we left Africa and then we figured out, oh, hey, we can plant wheat. It took us a good amount of time because we've left Africa about 65,000 years ago and we developed agriculture here about 11,000 years ago. Okay, so we developed agriculture here because Southwest Asia was very different at the time. Europe and Northern Asia, all through here, would have been frozen under an ice sheet. We were in a mini ice age about 11,000 years ago. So Southwest Asia would have looked a lot more like what Europe looks like now in terms of how green it was, in terms of the fluvial geography. You would have had these incredible rivers that would have been fed by the ice sheet that was melting right at the end of the ice sheet and would have been leading to a much heftier river channel here. If you were to go through Saharan Africa, you would see that there are ancient river channels that existed. So this was a much wetter place as well. So we had a lot more water, and river channels like these, the Tigris and the Euphrates, are the lifeblood of an ecosystem. What they do is they bring water, they bring oxygen, they also bring biomass. Rivers are an ecosystem in themselves. And that ecosystem has fish in it, it has plants in it. So all of that biomass feeds the riparian communities. Those are the communities of plants all along the Tigris and the Euphrates or all along any river channel there's a community of plants and a community of animals that have adapted to that river. And so the biomass and the oxygen and the water are all feeding the riparian communities. The riparian communities are cleaning that water. It's this incredible, beautiful, symbiotic relationship. So every once in a while, a river channel will flood when you have a whole lot of spring rain, when you have water coming from a gigantic ice sheet covering northern Asia, then you're going to get an extra flow of water, and that leads to a floodplain. So, right here where Mesopotamia would have developed, we have a floodplain. That water would have breached the channel, the banks of the channel of the river, and it would have brought biomass with it. It would have brought sediment. It would have brought silt, not to mention water, oxygen. All of that led to really, really good soil, iron-rich soil, um, humus-rich soil. Humus is the good stuff that plants want. All of that, and we had the other ingredients. So besides having great soil and great water, and remember, water would have brought, a river would have brought a nice water channel, but it also would have brought basically a highway for trade. This is how we would have traded as well. Okay, so why does my arrow keep disappearing? There it is. So the other ingredient that we would have found right in here were domesticatable plants. Remember, there are not a lot of domesticatable plants in the tropics. And the plants that are domesticatable, I'm sorry, that's my dog. The plants that are domesticatable are not staples. They're plants like sugar or like coffee. We love sugar and coffee, but we don't necessarily grow an economy and a staple trade on sugar and coffee. So we found domesticatable plants that were also staples. And they were wheat and barley and hops, and those are the ingredients for beer. So what we also developed besides agriculture was beer, and that was a real game changer for us. Beer is a sterile liquid, so it's a liquid that would have allowed us to get plenty of hydration without getting giardia um, or other bacteria in the water. It's also good calories, and so it would have allowed us to grow our population, sustain our population, all of that. So we started growing wheat. We started growing hops. People soon figured out that they could domesticate animals. The first thing we domesticated was the plant. I'm not the plant. What am I talking about? The first thing we would have domesticated was the cat. The cat domesticated itself. Basically, we had these stores of grain, and grain would have attracted mice, and mice attracted the cats, and we figured the enemy of our enemy is our friend. And so we figured out we could make friends with different animals. And from there, we started domesticating animals like animals that would have been found in Southwest Asia. I think in your class the other day, somebody asked me why we figured out dairy. Maybe it was in a different class, but it would have been because uh, you know we knew that animals produce dairy in the same way that humans produce dairy, and if you have something happen to the mothers in your community, or you have somebody who isn't able to breastfeed their child, then I think we would have made the leap into, oh, hey, there's milk being made by other animals as well. Okay, so we also figured out cheese. Somebody left a bucket of milk in the sun for too long and it curdled. This is a true story. This is how they think cheese was discovered, and somebody ate the curdled milk. So as we started to develop our grains, like barley and rye and oats, and as we figured out how to grow these things and grow a surplus, that's when we developed trade. So we began with plant agriculture, then we move into plant domestication, but then animal domestication. And so what we're talking about here is the first agricultural revolution. This is between 11,000 years ago and 2,000 years ago. And the reason that there's a difference in that number is because 11,000 years ago is Mesopotamia, but we had agricultural revolutions develop in isolation all over the globe. So if I go back here real fast to my map. So while our first agricultural revolution starts right here, our second agricultural revolution starts here in the Indus River Valley, and our third along the Yellow River. All of these would have developed in isolation, but for the same reason that agriculture would have developed here in Southwest Asia. They would have developed because you have good water, you have a floodplain, so you have that good soil, and you have domesticatable plants. And in all of these places, while culture developed a little bit differently, the main fundamental ideas of culture start in all these places the same way that they would have started in Southwest Asia. And I'll explain that in just a minute. So, the reason that we have this difference in number between 11 and 2,000 years ago um, is because our first starts in Mesopotamia 11,000 years ago, but then you have pockets of domesticated agriculture that continue to develop all the way to 2,000 years ago. Okay, so because they're developing in different parts of the world. Okay, so all of our first agricultural revolutions have to do with the use of seeds, domesticating plants, and then growing those plants to a surplus, specializing in the growth of those plants. So we would have had wheat farmers, we would have had down the road, you would have had a different type of staple farmer. We would have developed dairy farmers, we would have developed animal domestication, and people would have been focused on pastoralism, on sheep herding, and raising animals for meat and for milk and stuff like that. And so, with that economic specialization, you have the beginning of the economy, um, and you also have the foundation of our culture. Now, I know that I've talked about this. I talked about this after our last midterm when we discussed agriculture, or sorry, when we discussed globalization and the beginning of globalization. But just to remind you, once we start agriculture, land ownership becomes a thing. Land ownership had never been a thing for hunter gatherers. There was no need to stay stationary in one place. In fact, you wouldn't have survived if you stayed stationary in one place. You had to continue to move around so that you didn't use too many resources. Remember, that's our oldest issue is how do we get enough from the planet without overusing resources. So land ownership is something that develops, and with land ownership develops class. Now, for the very first time, if you're born into a society and you're born to parents who own more land, you're given a whole lot of advantages. In hunter gatherer societies, the only thing that would have mattered was your contribution to the society, your job within the society, and all of that would have been equally valued unless you were a leader or a shaman or something like that. But in our new post-agricultural revolution societies, land ownership became something that was very important. Where now, if you own more land, you're wealthier. You have the ability to not work because the majority of laborers through our first agricultural revolution wouldn't have owned their land. They would have worked for somebody else. And that somebody else could have completely removed themselves from agricultural labor altogether. That's how we have the development of our first cities in Mesopotamia. The people who would have lived in those cities, who would have been able to develop art, religion, the economy, they were all people who owned enough land that they were able to remove themselves from agriculture. They had laborers working on their land. So class and social stratification develops at this time. Marriage develops at this time. Like I've said before, now you own something, you have something to pass down to your next generation. So now that you want to pass down your land to your next generation, and we live in a society where that would have been patriarchal, where men would have owned the land, you need to know who your children are. So we developed this institution of marriage, which is based on the idea that that men can have sex with as many people as they want to in this new society, but it's important that women only have sex with one person because then the men know who their children are. So we essentially contract women to men, landowners, and our ideas about gender roles and sexuality begins. The idea that women aren't supposed to have sex with a lot of people, whereas it's natural for men to have sex with a lot of people, all develops as a result of land ownership and a result of needing to know who your heirs are so that you can pass your land down to them. So we have socioeconomic, we have gender, we have marriage, we have the development of the beginning of the economy, we have the development of economic specialization of cities. Of our first written story comes from our first agricultural revolution in Mesopotamia. So with the use of seeds, we also have the beginning of writing, and we have the Epic of Gilgamesh, which is our very first recorded story, which I explained in class is a story about a half man, half god, and a half man, half beast who fight and then become friends and then make their way through the countryside and through the wilderness. And it's essentially an allegory for for you know what's going to happen to us in the future, eternal life. Oldest story in the book. Okay, so we have our first agricultural revolution. Now, with our first agricultural revolution, besides the development of culture, all the stuff I just said, you have different types of agriculture. One is shifting cultivation. So shifting cultivation is where you can you can have a plot of land, and if you take that plot of land and divide it into thirds, you would leave one third open, fallow. You would use another third for planting certain types of plants, and then the third third for planting different types of plants. And then you would shift all of those so that you would have your second plot fallow, and you would develop you would essentially be moving your crops from one part of your farm to another part of your farm to another part of your farm, and leaving one part of your farm at all times without crops on them. That way the soil can rejuvenate itself. You probably would have herded animals on that part. Animals would have, they would have eaten the grass and they would have fertilized it by pooing. And it would have been this whole system where you were constantly transitioning what you were growing and what you were herding on your plot of land. So that's shifting cultivation. Intercropping, like I said the other day, is where you plant more than one crop on your field. So there's different types of plants that that help each other. An ecosystem is an entire uh, biodiverse community. It's an entire community of plants and animals that have developed to keep their population at a certain number, to nourish each other, to keep the soil rejuvenated. And when we create farms, what we do is we try to copy an ecosystem, but we try to copy it for our advantage. So what we do is we take different types of crops that are some like tomatoes, for example. Tomatoes leach the soil. They suck all the humus, that good part of the soil that plants love, out of the soil. Now, if you do just that, if you plant just tomatoes, what you're going to end up with is leached, dry soil. So what we do with intercropping is we take a tomato plant and let's say a bean plant, a legume plant. Legumes are nitrogen fixers. So what they do is they have this bacteria on their roots that allows them to basically take soil and create nitrogen. So you have legumes giving nitrogen to the soil, and you have tomatoes leaching nitrogen from the soil. And what you have is a nice balance of a little taking of nitrogen, a little adding of nitrogen. And there you go. That's intercropping. Different ways that we could intercrop. There's certain pests that love one plant and other plants that repel that exact pest. And so by intercropping, we could also create natural pesticides, natural herbicides. So intercropping is a whole bunch of different things, but it's essentially finding the plants that work best together to keep the soil so that it has humus and to keep pests and weeds away from the plants that we want to grow and cultivate. Pastoralism. Pastoralism, I know I've mentioned this word in class a whole bunch. Pastoralism is what happens when you have an environment that's not going to sustain agriculture. So remember, we need a floodplain for agriculture. We need good soil, we need good water, we need the biomass from that water, we need the minerals and the sediment from that water to keep our soil nice and rich. Plus we need the water to water our plants. Plus we need the channel for trade. But what happens when we live in the Sahara? Or here, this is going to be Mongolia. What happens when we live in a landscape like this? This is not a landscape that's going to be able to sustain agriculture on any kind of scale. So people who lived in these types of environments, they developed a type of agriculture called pastoralism, where you're essentially dependent on not plants, sorry. You're essentially dependent on animals like these. These are like a Mongolian goat. Um, and you herd them over long distances. So we're talking 1,000 miles, which means that your culture, once again, just like our culture in Mesopotamia that developed with land ownership, this culture is going to develop to be migratory. So what you're looking at right here, these are yurts. These are the types of um, housing that people in Mongolia would have adapted to their pastoralist economy. So these yurts you can set up for a good period of time. Inside a yurt you have like a nice round open space, and you can pack this up and you can move it. So you're not packing and moving every day. You're going to stay here for maybe a month and then you're going to pack up and move. Different parts of the world you're going to see pastoralism. Let me go back to my map. So here in Mongolia, just looking at this map, you can see how compared to different parts of, if we go over here to Europe, if we go to Western Russia, it's a lot greener. But here in Mongolia, you're looking at a cold desert. So it's not a place that's going to be able to sustain a whole lot of agriculture. So what you do is you pick up and you live right here for a month, and then you move, and then you move, and then you move, and that is your entire life. So think about what kind of culture is going to develop in that sort of an economy. How societies are going to be smaller. How marriage is going to be a thing for sure, but it's not going to be the same as what developed here in Mesopotamia. What's going to develop in Mongolia is possibly pluralist marriage, because it's not so important that you own land, but it is important that, where is my arrow? Sorry. But it is important that you are able to, you do have some ownership of flocks, ownership of maybe pieces of land. Some pastoralist economies work where you have shares of farms all throughout this area. So you still do have the social hierarchy and you still do have the need for marriage, but it's going to look different. You're going to probably see a lot more plural marriages where you have multiple wives and maybe one husband. Um, Sorry, my dog growling. So anyway, other places we would have pastoralist economies in the Sahara over here. Once again, it's a desert. Down in the Kalahari, which is in southern Africa. Up here along the northern part of Russia and in the northern Scandinavian peninsula, there's pastoralist economies. Their animal is reindeer. They actually literally herd reindeer all through northern Russia and the northern Scandinavian peninsula. And again, there's cultures that are uh, that have developed around that economy and also that pastoralist economy, but they would also change depending on what the environment is. It's going to be very, very cold up here, so your pastoralist economy would have adapted to that as opposed to the Kalahari. Okay, so pastoralism. Wet rice farming. Now, I've said in class a couple of times that 60% of the world's population is dependent on rice. So if 60% of the world's population is dependent on rice, then how we grow rice is going to affect all of us. Even if we're not growing rice here, 60% of almost 8 billion people, no matter where we're growing it, is going to affect the environment and the biosphere of the entire world. So, the way that we grow rice, that's pastoralism, that's not where I meant to go, sorry. So, the way that we grow rice, looking at this picture right here, we're looking at Vietnam. Vietnam is the second biggest exporter of rice in the world. China is the first biggest exporter of rice in the world. So, what we're looking at is a very mountainous place. Vietnam is very mountainous. There's a whole lot of stuff going on with their physical geography um, that leads to these mountains. I'm not going to get into here, but take physical geography in the future. Okay, so this is terracing. What happens when you want to grow something like rice that needs flat land and you want to grow it in a place that's very mountainous? Then you're going to create these little steps. So that's what this is. They basically cut into the side of the mountain to create these steps. And you have rice paddies. Now, the majority of the world's rice today is grown in a field where they soak the rice plant in water. Rice is a very dynamic plant, but it's a plant that needs a whole lot of water. Corn needs a whole lot of sun. Wheat needs a whole lot of sun and a whole lot of humus. But rice here in Asia, in East Asia and in Southeast Asia, rice needs a whole lot of water. So what we do is we soak our rice in water, and what that allows for is a cut down in pests, in weeds. Basically, if you're going to have something like rice, well, any kind of plant is going to attract pests and it's going to attract weeds. So if you can soak it in water, you're going to cut down on the number of pests. And that's great because that means that you are not nearly as dependent on pesticides and herbicides, synthetic combinations of chemicals that kill kill weeds and kill pests, bugs. But, so that means that you're not going to have the same issues as, let's say, corn has here in the US when it comes to the amount of chemicals that we spray on our land. But what wet rice farming does do is create a whole lot of methane. So, methane is one of our greenhouse gases. The atmosphere, and again, if you took physical geography or weather and climate, we would go over this in detail. But the atmosphere it has its fixed gases, like oxygen, for example. There's always about 21% of the atmosphere is oxygen. But variable gases that change in the amount that are in the atmosphere, those are our greenhouse gases. Those are our methane, our water vapor, and our carbon. And all three of those so-called greenhouse gases, what they do is they trap heat, they absorb heat. They're like little sponges in the atmosphere. So when we burn coal, for example, what we're doing is we are sending a whole lot of carbon. Gingy, what we're doing is we're sending a whole lot of carbon into the Gingy. Sorry. What we're doing is we're sending a whole lot of carbon into the atmosphere. That is something that hangs on to heat. Methane is 23 times the concentration of carbon. So methane has 23 times the concentration of carbon, meaning that it really, really captures heat. That doesn't mean that it's 23 times bigger, it's just concentrated. So its ability to trap heat is significant. And what's happening in these rice paddies is this water is a breeding ground for, besides rice, bacteria. And those bacteria are farting. For real, those bacteria are farting, and that is releasing methane into our atmosphere at a ridiculous amount. So while this rice paddy here is feeding the world, which is great, 60% of the world's population eats rice every single day, the way that we're farming it is sending a whole lot of methane into our atmosphere, and that's a real issue. Okay, and what do we do about that issue? There's different ways to farm rice, and I'm going to post a video on that that'll be on your canvas as well. Okay, Smallholder crop and livestock farming. That would have again been with our first beginning of agriculture. That's what we call subsistence agriculture. All of this is subsistence agriculture. It's basically how do we support ourselves and our community and grow enough of a surplus for trade. So, all of these are ways that we grow enough food that we can support ourselves plus trade. Wet rice farming, not quite. Wet rice farming is more an issue of today of our third agricultural revolution, and I'll come back to what the third agricultural revolution is. But all the rest of these are based on kind of small scale farming. This is where farming was in, from the first agricultural revolution into the second agricultural revolution. Okay, so I'm going to come back to this in just a minute. All right, so our second agricultural revolution, what we've been discussing is our first, but our second agricultural revolution here, that develops in the 1700s. So between the 1700s and the 1900s, we move into the second agricultural revolution. Now, the second agricultural revolution is higher crop yields, higher livestock yields. So we're growing more, we're we are breeding more animals. We see improved techniques. An ox yoke, that's this thing that goes around the neck of the ox. They develop different types of ox yokes that allow more mobility for the ox. It allows the ox to be more efficient in how much it's carrying. We domesticate the horse. We domesticated the horse long before 1700, but the application of the horse and the ability for the horse again to allow us more efficiency, our application of fertilizers and field drainage. Now, we used fertilizers before. The first agricultural revolution would have used fertilizers. And when we're talking about fertilizers in the first and the second agricultural revolution, we're talking basically about poo. We're talking about the poo that would have been from animals or in some cases humans. So China, our third oldest civilization, one of the reasons that they were to develop so efficiently and to develop so far ahead of the rest of the world is because one, their staple crop was rice, and rice, you can grow more calories per acre with rice. But two, um, they very efficiently used their stool. They used their poo for a long time. They had this whole system where you would take what's called your night stool, and you would put it out, and it would be collected in the early morning and distributed throughout the fields. And so at the time, you would have, because you might think there's a lot of bacteria in poo, and that is very true. But if you look at any herding animal, if you look at any animal like gazelles, if you look at animals like bison, they all have birds that follow them. And those birds, what they do, the reason that they're following them is because they're following their poo. And their poo is full of bacteria, and those birds, like chickens or whatever, get into it, and they pick out all of the bacteria that lives in it. And so what they're essentially doing is they're cleaning it, and they're getting their pay from that, right? That's how those birds survive. So what China and what other agricultural communities would have done is they would have had chickens. They would have had that kind of, with our use of animals here in the first agricultural revolution, those animals would have basically been working together. We had plants working together, but we also had animals working together. So using poo, like right from the animal or right from the human, would have been something that was more feasible and would have developed less bacteria, although you still would have had issues with bacteria. So when we look at China, for example, the use of night stool is one of the reasons that they became this incredibly strong, dominant civilization for so long. Okay, so that would have been a type of fertilizer. We would have used fertilizers back here. We would have continued to use fertilizers and develop stronger fertilizers, as well as we would have used pesticides and herbicides here. But when we talk about pesticides and herbicides in the second agricultural revolution and the first agricultural revolution, they're not the fertilizers we're talking about with our agriculture today. They are they're fertilizers like I keep saying, poo, but they're also There are also pesticides like ladybugs, for example. Ladybugs are carnivores, they eat other bugs. Herbicides, things that would have killed weeds, but not necessarily the herbicides we're discussing of today's herbicides, today's fertilizers. So what we did in the second agricultural revolution, is we took the first agricultural revolution and we made it more efficient. And the main catalyst for this, the main reason, is the Industrial Revolution. Look at how the second agricultural revolution is in line with the Industrial Revolution. It's because the Industrial Revolution comes along, it gets going in Western Europe. Western Europe has the coal, it has the land, it has the laborers, it has the waterways that were perfect for the Industrial Revolution. So did places like New York and the whole east coast of the U.S. Um, so the Industrial Revolution now takes laborers off of the land and sends them into the factory. So you had to get more efficient with your agriculture because we had lost so many laborers. With those laborers now going into factories, we had to figure out how can we more efficiently apply fertilizers? How can we more efficiently change um, what we plant and how we use our animals because we have lost a whole lot of laborers? Again, a shift in our economy leads to a shift in agriculture. With our first agricultural revolution, a shift in agriculture is what leads to our economy. But now we figure out how to manufacture things at a much higher rate. Basically, the mass, the sheer number of what we're manufacturing really grows with the Industrial Revolution. That removal of laborers from the farm, from the fields, and sending them into the factory changes how we have to farm. It also changes so many other things. It changes things like who did work where. Basically, on the farm, men would have worked outside and women would have done all the manufacturing at home because the Industrial Revolution leads to mass manufacturing. But before that, soap and beer and clothing and all that stuff would have been made at home and it would have been made by women. The Industrial Revolution changes that. It takes manufacturing out of the home. It takes all of the cottage industries that would have been part of communities and economies at the time, and it turns them into this mass production. So it commodifies the home labor that would have been done before. Um, it changes things on such a massive scale. And that's something I talk about in my economic geography class. And yeah, so I won't talk about it too much here. But so our second agricultural revolution continues into the 1900s. It basically follows the Industrial Revolution. So as the Industrial Revolution goes from Europe and from the US and begins to spread around the world, you see this more efficient way of growing food spread as well. Okay, so what about now? Now we are in the third agricultural revolution. And what does that mean? So so this would have been 1917. This is 1917. This is a college student who would have been studying agriculture. If you look at this, we're really looking at the beginning of the transition from the second agricultural revolution. Like, this is a plow. Imagine how dangerous this was, first of all, and how many accidents would have happened as a result of this kind of plow. But this is a very different way of farming than this. We have essentially removed ourselves in the third agricultural revolution, literally removed ourselves from the process of how we grow food to here, where we would have still, even though we had to get more efficient with the second agricultural revolution, there still would have been a lot more people farming. Whereas here with the third agricultural revolution, we've essentially automated our farming. Today, agriculture is still a giant part of the US economy, but it only employs about 4% of our population. So if you look at from the first agricultural revolution, when something like 80% of the population would have been employed by agriculture, to this sorry, to the second agricultural revolution, where we still would have had 40 to 60% of the population employed in agriculture. Today it's 4%. So we're still growing a lot of food, but we've done it in a way where we've removed people and we've replaced those people with agricultural systems that have changed a whole lot. And I'm going to explain those in just a minute. And with automation, with this. And we can really question how removing ourselves from this kind of farming to this has changed our relationship with the environment. I think that one of the reasons we think that we are not part of the biosphere, that we talk about the environment and we say things like we need to save the environment without realizing that we need to save ourselves because we're changing the environment. I think one of the reasons we think we can think this is is because we no longer are connected to the way that we farm things. We're no longer here. So let me explain what I mean by that, how we're not connected to the way that we farm things. So our third agricultural revolution gets going after World War II. So this is really important. It gets going after World War II. If we were in class, I would show you something on potatoes, but I'm going to post on Canvas a video about potatoes for you all to watch. Okay, so our third agricultural revolution gets going after World War II. And this is the basis of our third agricultural revolution. All right. It's based in monoculture. Mono means one, right? So monoculture means one thing that we grow. So now instead of having that intercropping, now instead of mixing plants, what we do is we grow one plant over and over again. So for example, Idaho is basically potatoes. This part of the US is basically corn, if not soy. We grow over 1,000 acres, let's say you have, and that would be now considered a small farm. That used to be a gigantic farm before the third agricultural revolution, but now 1,000 acres is just your basic farm. If we grow 1,000 acres of corn, we've removed the biodiversity of an ecosystem. And what we've replaced it with are synthetic fertilizers, synthetic herbicides, synthetic all kinds of stuff. And those synthetics are reliant on oil. Those synthetics are reliant on chemicals. And they get into our soil and they get into our water system. And they don't just stay here. So if we are putting a whole lot of fertilizers and herbicides into our soil, it gets into our water system, and then it gets into the Mississippi drainage basin. It makes its way out into the Gulf of Mexico, where we have a dead zone. What's happening right in here is we've had so many fertilizers come down the drainage basin that they have caused the algae through this area to bloom. The algae in this area bloom, and that sucks all the oxygen out of the water, meaning that other plants and other fish and all the stuff that lives here is dying. And that causes issues with the circulation of the water. Water has, whether it's a gulf, whether it's the ocean, whether it's a river channel, water has its own cycle of nutrients. It has its own cycle of biomass. And when we create something like a dead zone right in this area, what we're doing is we're altering that ecosystem, not to mention the ecosystem all through here. So with our monocultures, there are huge implications to this, to removing the diversity of our ecosystem. And some of those implications, like I said, are the use of these synthetic fertilizers and herbicides. Some of those implications are when you have a huge amount of corn, you now have to eat that huge amount of corn. So what we do with that corn, about 30% of it we feed to our livestock, to our animals. We have developed a way to cheaply replace sugar with corn syrup. So basically, as we started to grow more corn, we started to find more places for it in our economy. So our development of corn, or our growing more corn, our growing more soybeans, our growing more wheat, all of that happens with our third agricultural revolution, and that begins in the 1950s after World War II. The reason that it happens after World War II, there's a couple of reasons. We, we, the US, exit World War II as one of the wealthiest economies in the world. And we hadn't been wealthy before that. We made a whole lot of money off of the First World War and off of the Second World War. I know there's other implications. I'm not dismissing the the what happened with the military, what happened with populations in any way, but we also made a whole lot of money off of those wars. And so we go into the post-war era with a whole lot of money and with a whole lot of chemicals. During World War II, we here in the US, but also other countries in the world, had been developing chemicals. We've been testing things like the hydro bomb, the nuclear bomb, and we had this excess of chemicals after World War II, and we had to do something with it. And what we did with it was we figured out the third agricultural revolution, also called the Green Revolution. Today, we think of the Green Revolution as this wonderful, um, we think of the color green. Oh, it's St. Patrick's Day. We think of the color green as something that has to do with environmental consciousness, like reusing your bags and having metal straws and stuff like that. But the Green Revolution in this context refers to our removal of biodiversity and our heavy reliance on chemical fertilizers and chemical herbicides and all the stuff that we associate with agriculture today. So, our green revolution is something that's not actually super green. All right, we have this excess of chemicals. Those excess of chemicals after World War II, we used to develop synthetic fertilizers, synthetic herbicides. We essentially teach our plants how to grow closer together. So, one of the reasons that we're able to go in 1950, an acre of corn grew about 50 bushels of corn. So, 1950, an acre of corn grew about 50 bushels of corn. All right. Today, we grow on that same acre, whether it's Iowa or wherever, that same acre, we grow about 300 bushels of corn. So from 1950, 50 bushels of corn, to today, 300 bushels of corn per acre. What we've done is we have applied synthetic fertilizers, synthetic herbicides, but we've also taught our plants basically how to grow closer together. If you imagine the cornfield of 1950 as having the density of like a suburban small town, a suburb and a small town are two different things, but just imagine that density. Today, what we've done with our corn is we've taught them how to grow in what would be the equivalent of a dense urban population. So we've taken our corn from a comfort level of being several inches apart to being basically able to grow right next to each other. And we've done that by creating hybrid stalks of corn. We've done that by changing the consistency of our corn, where today our corn is grown with the majority of. So if you looked at our corn kernel, the majority of it is. It used to be a carbohydrate, but now you see a whole lot of glucose, a whole lot of sugars. Um, we basically taught our corn how to grow in a very different environment. So all of this is the implication of the third agricultural revolution. The third agricultural revolution being taking away diversity of the farm and growing just one thing without monoculture, applying synthetic herbicides, synthetic fertilizers, and starting to play around with the genes of plants. So you have probably heard of GMOs before, genetically modified organisms. But GMOs and the gene revolution have to do with each other. They're not always the same thing. A GMO is where we get into the cellular level of the plant. And if we get into the cellular level of the plant, we can change it. Basically, we started this with the new leaf potato. The new leaf potato was this potato that we figured out, hey, if we could get into the cell of the plant and basically give this potato a resistance to the pests that want to eat it, Well, that would be great because then we wouldn't have to spray our fields with so many fertilizers. So, what we did is we took the potato at the cell level and we tried to alter that cell so that so that we could so that we could basically build in a resistant to the pests that want to attack that potato instead of spraying that potato. That's a very good idea. But the issue is we don't actually know the long-term effects of how changing a plant at its cellular level and then eating it is going to affect us. That's the controversy with GMOs. The controversy is, what is the long-term effect of changing the genes of the plants that we're eating? So the idea was, how do we cut down on synthetic fertilizers, synthetic herbicides, all that stuff with GMOs? The problem is that, are we just replacing one problem with another problem? So the gene revolution has to do with that, what I just explained, but it also has to do with, like I said, teaching our corn how to grow closer together. And we can do that by splicing plants. So that doesn't necessarily require us to change the cellular level. What we can do is we can splice plants together. If you think about an apple, for example, the inside of an apple has seeds. Those seeds don't necessarily grow the same kind of apple of the apple that the seeds came from, if that makes sense. So if you have a red delicious apple, the inside of that red delicious, you'll have a number of seeds, but those seeds don't necessarily grow the same red delicious apple. So the way that we grow red delicious apples today is we splice. What we do is we take like a piece of a branch, so a piece of the red delicious apple branch, and we tie it to a new growing apple tree. And that way we create this splicing. Now, see the way that we don't change it at the cellular level, like with a GMO, but we are messing around with how that plant is growing? That's a very different thing than a GMO. Also, that's how we create hybrid fruits, like we have a pluot, that's a plum and I think an apricot. We didn't change the cell of that plum and apricot. What we did is we basically just took two living plants and we taught them how to grow together, if that makes sense. So that's our gene revolution. And that's all part of the Green Revolution. The Green Revolution post 1950, post World War II, in the 1950s, using the excess of chemicals that we had left over from World War II to create synthetic fertilizers, synthetic herbicides, synthetic pesticides, taking away the biodiversity of the farm and just growing one thing, and then having to implement that. When we started growing a lot of corn, we didn't use that much corn. So in the 1950s, we start to grow more corn. Now we have this surplus of corn. So people started to feed it to their cows. So then now we figure out, oh, hey, cows who eat corn, they actually grow fatter much faster. And it cuts down the cost of growing that cow. Now, it's not good for the cow. It's terrible for the cow. It tears their stomachs apart. They have 4 stomachs. But we figured, hey, we have this surplus of corn, and if we feed it to the cow gets bigger, it gets fatter faster, we can slaughter it faster. I'm sorry, vegetarians and vegans. Um, and we and it made good business sense, but in no way am I saying it made good sense for the animal or for the farmer. So the reason that I'm using this as example is not to dehumanize the cow. It's to explain how with a monoculture we have an excess of something and people started to use it. And so now, several decades later, we are dependent on that monoculture. In the beginning, we started to grow a lot of corn and we found uses for the corn. Today, we're at a point where our entire agricultural economy is reliant on that corn because we started to implement it with things like corn syrup. Corn syrup was very expensive at first, but it was very expensive at first. Um, but we figured out how to make corn syrup pretty cheaply because we had this excess of corn, so we played around with it. And now we are reliant on that cheap corn syrup. So it's harder for us to remove a monoculture now that it's so thoroughly implemented into our agricultural system, is the point that I'm trying to make. Okay, so with our monoculture, with our green revolution, with our gene revolution, with our messing around on a biotechnology level with GMOs, we've changed the way that our agriculture is grown. And we are now growing mass quantities. We grow enough food every day in this world to feed 11 billion people. 11 billion people. We only have 7.5 billion people. I know only, people are like, only, okay, you know what I mean? But we grow enough to feed 11 billion people. So, what do we do with that? Because while there are people who have access to a lot of food in parts of the world, there are people who do not have access to a lot of food in parts of the world. What that has to do with is distribution, for one. We grow a lot in excess here. We don't necessarily grow in excess in other parts of the world. And it also has to do with how we waste about a third of our food. So while we grow 11 enough food for 11 billion people to eat, we throw away about a third of it. And we do that across the board, all over the world. All over the world, we throw away about a third of our food. Part of that is because some food rots. I mean, you just can't get it from farm to market fast enough. Part of that is because uh, we have these ridiculous expiration dates on our food. You know, we buy food from the grocery store and it says best by whatever, and those dates are for the grocery store. They're not for us. But we get them home and we see, oh no, this was best by, 2 days ago, so I need to throw it out. When actually those numbers have to do with liability for grocery stores. They have very little to do with the actual quality of the food. For example, milk is supposed to be good about 7 days after that best by date. Eggs can be good for as many as 6 weeks after that best by date, but we end up throwing out that food because we see a date on it. Also, there's a good amount of food that never makes it to market because it's not considered pretty enough. If you have a peach that grows with like kind of a funky slant to it, that's something that doesn't actually make it to market. So we throw away a good third of our food, and like I said, that's everywhere in the world. That's every agricultural community in the world, um, across the board, pretty much throws away a third of its food. Okay, so our green revolution. One thing about our green revolution is it definitely has led to more food in the world, but it has increased the production of biomass fuel. Sorry, decreased. It's decreased biomass fuel. And that is that's an issue for a couple of different reasons. But the main issue is that it's decreased that biomass fuel and it's replaced it with fuel that is based in burning carbon. So with coal, with oil, either whether it's being implemented in our fertilizer or whether it's being replaced in what we're using as energy in our household, we have decreased the production of biomass fuel and we've increased the production or the use of carbon-based fuel that releases carbon into our atmosphere. And like I said earlier, that's a greenhouse gas. It's also reduced crop diversity. And remember, our biosphere is a balance. Our biosphere is an entire community of plants and animals. And what we do when we create things like a monoculture is we take away that natural diversity that protects certain plants, allows other plants to grow, allows some plants to take up all the humus in soil, and other plants like beans to add nitrogen and replenish that humus. So by taking away that diversity, we've replaced it with synthetics like fertilizers and herbicides that are their main ingredient is oil, and they get into our soil, they get into our water, like I explained earlier. And this is a real issue, replacing this diversity, because our planet runs on diversity. Another important part of the Green Revolution. So I said that after World War II, we had an excess of chemicals. Well, after the Vietnam War, we also had an excess of chemicals. And that's when the company Monsanto gets going. So Monsanto, I should have later, where is Monsanto? Monsanto. Monsanto is a company that gets going in the Vietnam War. They're the people who develop Agent Orange. Um, they're they're a chemical company, and so after the Vietnam War, when we were again messing around with chemical warfare, we had this excess of chemicals, and so Monsanto takes those excess of chemicals and from Agent Orange, and it uses them to develop um, uh, these synthetic fertilizers that Monsanto now markets. So Monsanto is, some people think of it as like the worst company in the world. Basically, what they've done is they've created, they messed around a lot with GMOs for one, but they also created this whole system of synthetic fertilizers and herbicides that only work with their plants. So what they've done is they have they've taken they've taken their excess of chemicals and they have developed a type of fertilizer and a type of herbicide and a type of pesticide that kills all the weeds and the pests that are trying to eat your potato or whatever. But they've made that potato or that soy or whatever their seed is resistant to what's called Roundup. So they've developed this system where they have a seed. You can spray their fertilizer all over, or sorry, their herbicide all over the seed, and it's not going to kill the seed. It would only kill the weeds that want to kill the seed. And again, that's good. That's genius because it allows you to grow your plant and grow it efficiently. But it relies on a whole lot of chemicals. It relies on a whole lot of oil that get into our soil, that get into our water system and are degrading our environment. But also, Monsanto has grown into this company that has patented their seeds. And by patenting their seeds, they can sue anybody who's using their seeds who hasn't bought their seeds. And you might think, well, yeah, that makes sense. But the issue there is that our our earth doesn't work in the way where it recognizes private property. So if you have a farm and you're not a Monsanto user, but your neighbor is, their seeds might blow onto your farm. And so if you are caught growing, even accidentally, seeds from Monsanto when you are not contracted by Monsanto, they will sue you. And you might think that's ridiculous, and it is ridiculous. The reason that they're doing that is because Monsanto is a gigantic company and a farmer is just a farmer. You know, they don't have a whole lot of financial resources. So what they're doing is they're scaring farmers into using their seeds and into using their products. Basically, they can sue you if you are accidentally growing one of their plants. And remember, the wind could blow a seed into your farm and you don't even know that you're growing this plant, but they'll still sue you. And the reason that they'll do that is they have all the money in the world and you're a farmer who's making $18,000 a year. And so they know that by intimidating people, they will be able to get people to just buy into their products simply because they don't want to get sued. That's one of the reasons that people think that Monsanto is one of the worst companies in the world. That and their effects on the environment. And remember, Monsanto got going with the Vietnam War, and the reason they go into agriculture is again because of an excess of chemicals. So chemical farming, we really start in the 1950s, but by the 1970s, this was a very normal sight. This was actually one of the jobs that my dad had as a crop duster, meaning that he sprayed sprayed pesticides and herbicides on crops. He would have sucked all those pesticides in too, but still 82 and walking around, no consequences for him. Anyway, we have our chemical farming, the use of chemicals that grew, like I said, after World War II and after the Vietnam War. And then we also have food manufacturing. Food manufacturing is the preservation of food, for one. So preserving food in a in like sardine cans or whatever, pickling them, but doing it on a wide manufacturing scale. But it's also the manufacturing of things that we've never seen before. So using preservatives in things like Twinkies, for example, a Twinkie never goes bad. It has an expiration date on it just because it's supposed to, but it will actually like never go bad because of the amount of preservatives in it. That's considered food manufacturing as well. Also, things like Sweet and Low. Sweet and Low never doesn't exist anywhere in the world. I mean, I know a stripper named Sweet and Low. She exists, but besides besides Sweet and Low, her the little pink packet that you get um, and put in your coffee or whatever, that is completely manufactured. So that's the other part of manufacturing as well. One is the preservation of food over a long period of time, either by canning or by adding preservatives. The other is the development of things like Sweet and Low that don't exist anywhere in nature. They're basically just a combination of chemicals. The blue revolution goes along with the green revolution. The blue revolution is so if the green revolution is the use of synthetic herbicides, fertilizers, stuff like that, the blue revolution is the use um, of farmed fish. So fish live out here in the sea, but we've created farms for fish. And sometimes that's not a good thing. Like with salmon, for example, salmon need to be running free, swimming free. You know what I mean? Um, and when we farm them, we basically put them in these gigantic tanks, and they go around in circles and they eat their own feces, and it's terrible for them. So we want some fish to not be farmed, but some fish, like tilapia, for example, farmed here in the U.S., that's actually better for their fish population to be on a farm. So if you're curious, if you're concerned because you want to eat the right type of fish, you want to eat fish that have been treated well and also that aren't swimming in their own feces and stuff like that. Why did I start saying feces now when I said poo like 100 times earlier? I don't know. Um, but so when we look at sorry, when we look at like how certain fish actually do better with farming, how other fish need to be caught in the wild, the Monterey Bay Aquarium has figured all of that out for us. There's an app that you can download on your phone, or else there's like a little guide that you can keep in your wallet for when you're buying fish. Because I know that you are concerned with the health of our environment and the health of the fish that you're eating if you're eating fish. And some fish are better off. It's actually better for the environment for them to be farmed. And other fish, it's better for the environment for them to be caught in the wild. So check that out. Monterey Bay Aquarium has a guide for which fish you should stay away from altogether, which fish should be farmed, which fish should be caught wild. So that's part of the Blue Revolution, is the introduction of farmed fish. And the good thing about farmed fish can be that it takes weight off of our fishing in the biosphere and it allows those populations to naturally rejuvenate without breaking down their numbers. But again, check with that guide because some fish you want to be wild, some fish it's better for them to be farmed. And also, country of origin really makes a difference. Farmed tilapia in China, not a good thing. Farmed tilapia in the US, a good thing. Okay, the other part of the Blue Revolution is the use of large boats. So, motorized large boats, the ability to get bananas from Chile or from Guatemala and very quickly move them into the mid latitudes. Chile's in the mid latitudes, but it's in the southern hemisphere. So, if we're growing something, because the southern hemisphere is on the opposite season that we are in the northern hemisphere, basically, if it's summer in Chile, they can grow things that we would grow in summer, and vice versa. So, with the implementation of these larger boats, that move very quickly around the world. That's why we can basically get produce at any point of the year. Pineapples in Boston in the middle of winter were not possible before the Blue Revolution. Now, again, I'm not saying this is necessarily a good thing because it relies on a lot of oil. It creates a whole lot of traffic. There's a whole school of thought in eating locally and eating plants that are grown closer to you. It contributes to your local economy. It doesn't use the water resources of periphery countries, all that good stuff. So if we look at shrimp, for example, shrimp is a type of fish, I actually don't know if it's a fish, that we love, and shrimp comes from here. But like I said, we have been destroying the Gulf of Mexico and we've created a dead zone right in here. But we don't necessarily stop eating our shrimp just because they no longer can be caught here. Now think about the economic devastation to the people in places like Louisiana, in Alabama, places that would have been, their entire economy would have been based on catching shrimp, catching red snapper, all that stuff. Those economies are devastated because of this dead zone, not to mention the environmental damage. But we don't stop eating that shrimp. What we do is we import it. And we import it from places like Thailand, from places like Indonesia. Indonesia is using a whole lot of slave labor to catch that shrimp. You have people, and I think I've mentioned this in class, who are kept in cages in Indonesia who are enslaved and catch shrimp all day. And that's why transparency, that's why we want to know where our products are coming from, because I know that none of us want to be contributing to that kind of labor economy. So the US here and Japan, we're the number two, or sorry, not the number two, we're the two leading importers of shrimp. That's because shrimp is a big part of our culture. Here in Japan, obviously they're surrounded by water, and shrimp has become a central part of their cuisine. And here in the US, because of Louisiana, because of the Gulf of Mexico, shrimp has become a major part of regional cuisine. But with environmental destruction, we've just started importing it rather than changing our culture. Okay, so the last thing with agriculture I want to say is we're at a point in our agricultural economy where we have completely changed. We've developed from our first agricultural revolution to our second agricultural revolution to where we are today with the monocultures, with the use of synthetic fertilizers, herbicides, and we are increasing deserts. So we're increasing the number of deserts, or the acreage of deserts, by about 20,000 acres every year. So we're seeing 20,000 acres more of deserts every year because of the way that we are leaching the soil in the world. We need to stop that, and we can stop that. We can stop it with habitat restoration. We can stop it by changing our agricultural practices. I know a lot of people think we are now stuck in the type of agriculture that we use because it creates so much food. But we would actually create just as much food with mid-scale organic agriculture. Mid-scale organic agriculture, and that is a agriculture that is more sustainable. It's better for the laborer, it's better for the animal, it's better for the environment, it's better for the farmer, all of those things. So if we were to throw our money into mid-scale organic as opposed to the type of agriculture that we throw our money in today, that would make it more profitable. A lot of people say, well, mid-scale organic, mid-range organic can't survive. But if it were the profitable model for agriculture, that's what would become the dominant model for agriculture. And I know you're poor, you're community college students. So in no way do you have to transition to mid-scale organic like right now, but with little choices that you can make, that you're able to make. So desertification is something that we see growing, and salinization. That's where essentially we have all kinds of minerals in. So let's say we take the Aral Sea, for example. The Aral Sea used to be the fourth biggest sea in the world. and now it is 95% smaller. So once upon a time, it was the fourth biggest sea in the world. It's now 95% smaller since 1960, and that's a result of how the USSR used water. Basically, the USSR wanted to make Uzbekistan, Kazakhstan, their breadbasket. And so they took all the tributaries, all the rivers that would have contributed to the size of the Aral Sea, and they rerouted them. And so what that did, if the Aral Sea is no longer receiving water, it's going to dry up. And that's exactly what it did. It shrunk by 95%. So what happens after you once had a body of water and now you don't is all the minerals that would have been in that body of water, and you can have salt in water even if it's not a salty sea. I mean, um, this was a salty sea. Seas are salty, but what I mean is you can have a body of water like a lake, for example, a freshwater lake, that if it dries up, you're still going to see the same process of salinization. And so what happens is you have the water evaporate, but that water vapor leaves behind any minerals. So if there's salt, if there's anything in that water, it's now just left on the soil, and that's salinization. Now you have this accumulation of salts and other minerals that continue to dry out the soil, especially if they sit there and they're heated because of the sun. This is an issue we see here in the Aral Sea. This is an issue that we see in the Owens River Valley, which is in California. We basically took all the water from the Owens River Valley and we moved it to Los Angeles starting in the 1920s, and we saw salinization of that entire area. That's something you would learn about if you ever went on the Eastern Sierra field trip that our Earth Science Department has every fall. Okay, so there's some desertification in the Sahel, and we're seeing it, like I said, and an increase of 20,000 acres every year. And that's it for agriculture. I don't want to leave you with that very sad note. So the note I'm going to leave you with is that we know how to grow food more sustainably, and we know how to grow a lot of food. What we need to do is take the good parts of the Green Revolution, the parts that taught us how to grow food more efficiently, the parts that taught us to use fencing that could keep out wild animals and protect chickens, but that could also be moved around so that those chickens could graze in different parts of a farm. That's just an example. We need to take the good parts of the Green Revolution and apply them to what we know about mid-scale organic. And that's the way that we're going to continue to stay alive as people, get enough food, and not continue to degrade our environment the way that we've been doing it. We have the ability to grow food at a very, very high capacity, and we have the technology and we have the intelligence to know how to do it without destroying our biosphere. We just need to do it. And one of the ways that we can do that is by throwing our support, our financial support, our audible support into that style of agriculture. We're smart enough. You are all smart enough to allow us to sustain our population and do it in a way where we can live very well in the world. So that's it. I'm going to have a couple of videos posted that go along with this lecture, the thing on potatoes. I'm going to post something on cheese. There's a TED Talk by Joe Salatin, who is a mid-scale organic farmer that I've posted as well, so please watch those. And look for your midterm questions on Thursday. I'm going to post them on Thursday, and you'll have 24 hours to finish them. Okay. Now I have to figure out how to stop this.